it until everyone who wants to joins the session. So we will start in approximately 2 minutes. Okay, hello everyone. First of all, I see there are one moment. Yeah, need to switch microphone. Hello everyone. Welcome to today's session. Um, First of all, thank you for all those who shared the. I think for those of you who shared the. I think I have some problems with the audio. Is it correct or not? Hopefully not. Okay. Yes, I think it should be fine now. Yeah, if I have any problems with the audio, please write it in the chat. Right. So yes, again, thank you to all of you who shared your repository with me. I think that almost everyone managed to do it. I haven't checked how many of you have done it, but I see there are lots of people. There are almost every one of you shared with me. Thank you, and once I once we have the once I check the homework, I will check as well how many of you managed to do it. But if anyone still has the problem with sharing with Git, then please please write me. I will try to help. So yes, regarding the session we had last Saturday, if there are any questions, any unclear details, please let me know. Today we'll we'll try to mainly focus on the practical side of the session we had on Saturday. So we will try to we'll try to refresh the knowledge of all the things we've gone through on Saturday. And so let's start. Again, if anyone has any questions, please ask so we can discuss it during today's session. Right. So let's start. Yes, as you remember, we had lots of things discussed this Saturday. Lots of topics related to object-oriented programming. Not all of them, but main of them. So we can have some practical tasks now. As you remember, last time we had the topic related to constructors, about Java constructors. So now let me share some examples with you, so you can just repeat it for yourself and maybe to find it better how it should work and how it works and how it should work. Right. Yes, for this purpose we can create class. Let's go with test constructor. Let's create a static method so we can run it, read it. Then again we have the public class from the package which refers to object-oriented programming. Okay, yeah. If it's regarding your personal questions about the things which are not working, I will try to answer you after the session or during the break today. Right? Yeah, but if you have any general questions, you can ask it in general chat, so we can go through them. Right. So again, now we have the public class test constructor from the package OOP, and yes, let's create the constructor. So here's just a simple constructor. Here, constructor, as you remember, constructor should have the same name as the test constructor. Sorry, yeah, should have the same name as the class has, right? And by default, the constructor is defined as public, but again, we can change the modifier, so no one will be able to create the instance of this class outside this class directly using operator new. Right. Then once the object is created here, so now we can create the object which has the type test constructor. Let's call it instance. Then we create a new instance of the class, and now the instance will be created. As you can see, since we are in the same class, as this constructor is, so we can call the constructor. We can create an instance because we are inside this class. That's why we can access the constructor, which is defined as the private one. So if we create another class like test constructor 2, for example, and if we want to, let's just have the same method here. Again, you can see that we cannot create the instance because it is because the constructor is defined as private. The same as for all the methods in object-oriented programming. The option to maybe skip this or to make it to make it able to return the constructor, to return the instance of the class test constructor. You can create public static test constructor, which will return the instance of constructor test constructor. Then we need to create let's go to get instance method, for example. Get instance method. Yeah, we need to return. Then we can return the instance of the class test constructor. Right, and using this way, as you can see, we now have the static method. So it means that, again, as I said, all the static attributes and methods belong directly to the class itself. Right, so we don't need any instance to call the static method, and that's why we can call it despite we don't have the instance of the class itself. But we have the class, but we don't have the instance of the class. So the object which refers to this class. Right, and here we can call the method get instance, and that's the way how we can get the instance of the class where we don't have where the constructor is defined as private one. And yes, again, another point is that you can see that there's just an access modifier before the constructor and nothing else. That's why it means that it is constructor, not the method, not the void. If we create it this way, so let's just copy here. In this case, this one will be considered as the void, not the method. And it's not the constructor, but it is a method. But yes, this is a bit tricky and not so clear. That's why I tried to escape naming the methods using the name of the class. Leave it to constructor, and that's it. And again, you can overload the constructors. It means that in case you have in this case there is a constructor without any parameters passed. In the same way, you can, let's, for example, if we have the attribute of the class private, let's call it just just integer. Let's assign default value 0, for example. In this case, if we want to pass the parameter a, then we can, for example, do it this way. In this case, we do the overloading of constructor, and now we have two constructors with the different parameters. So the first one has no parameters, and the second one has the parameter. And right, in this case we call this constructor, because we don't pass any parameters to the constructor. But if we pass the integer number to constructor, like for example 3, then in this case this will call this constructor, because we just passed the integer number as the parameter. Right, and yeah, this is example how we can overload the constructor. And let's just was just pretty sure some basic simple example. For example, we system out print when structure with no parameters code. So yeah, let's add the semicolon and then yes, use don't forget to use Ctrl Shift plus F, which will format the code so it will make the code more readable. Then in this case we just can constructor with just with one parameter called. Right, then we can run the main method. Yeah, we have two methods here. Yes, as you can see, first of all, since here, so we have static method void. As you remember, this is the start for each program, start method for each program. Then here we can see we create the instance of the first using the first constructor, using the constructor with no parameters, the first one by the sequence we defined. And as you can see, it is called here from here. And after that we call the constructor by passing the parameter. And after that it shows us that we are in the second constructor. Right. Yes, and by default, again, all the Java classes do have the constructor, but if you not define it here, it will just be used as the default one, as the public one with no implementation. Right? Okay, let's move on. Let's move on. Yes, this is about constructors. Yes, again, constructors are used to initialize the instance, to fill all the necessary parameters once the object is created. So we use it for this purpose. Right. Let's move on. As you remember, we had the static constructor, which can be defined this way. You can use static one, static, just static, then it is just a static section, and here we can static constructor is called. We can actually not pass any parameters to static constructor because of the way it is working. Why we can't? Because the static constructor is not called as actually in the way the methods are called. As you can see here, we write just to remove the brackets. As we can see here, here we pass the operator new. No, but we write the operator new, and after that we provide the class name, and you can see the brackets. As you know, we use brackets to call the methods, and in this case the constructor has lots of similarities with the methods. So it has the brackets where the parameters can be passed, and in this case it makes sense that we can pass the parameters here. Why we can't do it for a static constructor? Because we actually haven't the place where to put the parameters, because as you remember, the static constructor, let me show it here. should work. Let's check. Yes, as you can see, the static constructor is called, despite the fact that we actually have no any specific call for this constructor. Again, here for just simple constructors, let's call it instance constructors, we do have actually something like method call in this case. But for static constructor, we just have nothing. Static constructor, as you can see, it will be called for, again, as I said during the last session, static constructor is called at the moment when the class is accessed for the first time during the execution of the program, of every program. So as you can see now, let's just, for example, let's create just now we have absolutely absolutely nothing inside the main void here. Let's just run it, right? And as we can see, despite the fact that we actually have nothing inside, absolutely nothing, so we have no implementation inside the main method, but despite this fact, the static constructor is called. So again, let's imagine it in the way that once we touch the class for the first time, this will be called. So since here we just executed the class, it calls the static constructor, right? Yes, this is the way how it works, how it normally works, and yes, this is about static constructor. So let's move on. Another point we discussed on Saturday was yeah, in case you have any questions about the constructors, please ask it in Discord. And let's move on. Another point we discussed on Saturday was the way reference variables actually work. And test reference, for example. And as you remember, we had just let's create two attributes here. Okay. Now we have two attributes, and now we can create the instance of the class. Maybe let's write the constructor again. Test ref. Let's pass two parameters to the constructor, and let's just point again. We use I recommend, and in this case we need to use this keyword to point that we actually want to access the attribute from the class, not the one just passed to the method. But if we not provide the keyword this as here, in this case it will consider this variable as the one just passed to the method, and yeah, the same way was B. Right here we can create the instance of the class, which should have the type of the class, test-ref instance class new. Then we call the constructor. Again, in this case, you can see that we cannot create the instance of the class because this way, because actually we have the only constructor, we have the only constructor which has two parameters to be provided. So as you remember, as I said, that all the Java classes actually have the constructor. By default, you can you can choose to not implement it. In this case, you will not see it here, but it will actually and it will be just an initial one with no parameters. But in this case, if we create at least one constructor, at least one implementation of constructor without any overloading here, yeah, and if it has the parameters, in this case it will skip the default constructor and will just check for the one implemented. So in this case, it's not able. In this case, we cannot use the default constructor, which has which has no implementation inside and which has no parameters. If we have at least one constructor, we must use it, and we cannot use the default one with no parameters. Right? So here we need to. Okay, let's create. Let's just distinguish instance one. Let's pass the two parameters here. So now everything is fine. We just pass the parameters needed. And let's imagine we have another instance, instance 2, and let's just pass the instance of the first. Not this. Yeah, just you can use this operator just for class attributes, and you can. In this case, you cannot use it because this is considered as the object we are currently in, and in this case you can see that this is the static method, so here there's no constructor. Here there's no constructor even in case we have the method. This is just for, imagine this void is non-static one, main2. Even in this case we cannot use this because this belongs to the class, actually to the object which refers to the class. So it belongs to the object we are currently in. In this case, we have no instance defined as the global attribute. Despite that we have instance here, this will access the attribute from defined globally, not locally here, right? So in this case, you just need to know that this is not used for the local. For the local variables, it's used for global variables only. This is just a small remark, so you don't miss it, right? And in this case, we do not use this keyword. This is used for the object if we are inside the object. And yes, and now let's just test it how it works. System out print ln, right? Here we can write the output so we can check how it works. Equals, let's go this way, equals plus instance right, and instance b. Let's go this way so we can. Yeah, we add the space to just have the space between these two statements, right? Here, just copy the one. So we'll do the concatenation. Yeah. So as we can see here, okay, maybe let's create the same output for the second one so you can you can check it directly. Yes, let's run it, and as we can see, they both are the same. Yeah, that makes sense because we just pass the parameter here. Again, if we change the variable a inside using the second variable instance too, here let's call it like, let's change it to 3 for example, and let's run it now. As we can see that here, yeah, sorry, that's my fault. We need to change, to pass here. And yeah, here we can see that even if we change the attribute using the second variable, it changes the the variable which is located under the reference of the instance created here. Yeah, so if we pass the instance, if we pass the reference to a different variable, it will be still working in the way that if we change the values inside the first one or the second one, it will work. It will change the variables which are located under the reference here, under the here, right under the reference of which is assigned to this variable. Yeah, it pretty makes sense since that's the way object-oriented programming works. But yeah, how to, for example, if we just want to have the variable with the same values as the source. In this case, this is the source one, right? Let's call it the source variable, and let's call this as the target variable. So in case we just want to have the same values, but we don't need to have any links between them, in this case we can use the method which is called clone, and okay, that's okay, that's okay. Yeah, the problem is that it returns a copy of the object, and as you can see, the returning type is object, and in this case we need to actually find a way. We want to pass. We can cast the object to a new. Yes, in this case, let's for example do it. Define it as object. So as you remember, the object is the parent class for all the classes, right? And that's so all the classes are inherited from object, and let's okay. In this case, it will clone the instance one, but okay, we'll continue with this one under the break. I'll just need to check one thing, but yes, we'll get back to it after the break. But let's move on now. Let's move on. Yes, we'll get back to it. Yes, one more thing we discussed on Saturday is so-called pass by value. Pass by value parameters which are passed by value. So pass by value. As you remember, all the parameters in Java methods are passed by value. And if you are familiar with other languages where the object-oriented programming is used, for example C, C++, there are two options how the parameters can be passed. So the first one is passed by reference, which actually means that we just pass the variable which can be changed inside which can be changed inside the method. So it means that we just pass the same point to the memory into the method. So we just have the variable which is pointed to the memory, which has the address from in the memory, and we can pass it to the method. So it works this way. But in Java, all the parameters are created in the way that it will create the actual copy of the parameter passed. So if you pass the parameter to the method, once the method receives this parameter, it creates the copy, and it will have no linkage with the parameter you passed to the method. So in this case, let's just create a private void. Private void. Here we have the just one parameter. So in case we change it here, let's for example change it here, then let's just have example 2, just a simple example here, and yeah, again let's create the object, the instance of the class. Yes. And now we can so name pass right, and now we can pass the parameter to the method, and after that let's check what happens with the variable a. As we can see here, we pass this parameter and we assign a new value here. And how it works here, it works in the way that the value remains the same despite the fact that we changed the parameter a here. So as again, it works in the way that here inside the method it creates the actual copy of this parameter, this variable which is passed here. Right? If we actually have the instance of the object. Okay, this method, let's assign a value here. Then we just don't need. Just not in here. We need But again, we need the instance. We need the instance, and yes, and now let's pass this parameter to the instance of. For example, let's imagine we have 2 here, and now we pass the instance of the method, an instance of the object, and yes, here we just it's a bit tricky. It may be a bit tricky. Let's just create instance. Let's have instance 2, just to distinguish them. Yeah. And it's still a bit tricky, but okay. It is not so important here. And here, as you can see, we changed the value of the global attribute from this class, which to which this instance is referred, which is passed from here. And here you can see that initially we passed parameter 2 to this instance. Then let's check it here. As we can see that the value is changed. The value of the global attribute A, which the value of the global attribute A of the instance of this instance, which refers to this class, is changed from 2 to 1. So as again, as you can see here, despite the fact that it creates the copy of this of this variable, in this case it will use the same instance. If we do it this way, like have instance, just sorry, I have no good imagination, so I'm just using instance 1, 2, 3, and so on and so on. But I hope you can understand it, how it works. So just add the type. This is actually, yeah, one small remark, and this is what I don't really like why the Java has it, because as you remember, as I said from the first session, that Java is statically typed. So in this case we need to point to the type which will which this object will belong to, right? So in this case, if we don't provide this, it shows the error. However, from my point of view, if we actually pass the class name here, why, for example, why this one can be declared automatically without the typing. Lots of other programming languages do have such most of scripting languages do have such option that we don't need to point the class name, but in Java we need to do it always, because Java again is statically type, and this is the case I don't really like, and don't really understand why it should be this way. And again, we have the exact class of which we want here. Why can't we just state this way and use kind of the point that this is declaration, and don't put this type here? But okay, we need to do it this way, right? Okay, so now if we change the value here, for example, and put a new reference here, instance here, if we do it this way, then we can actually see that the global value the value of the global variable a of the instance variable, which is declared here, remains the same as it was passed here, despite the fact that what we've done here, we just created a new instance, then we assign a new value to, in this case we just assign an initial value to a, and we pass the instance from this variable to the variable passed to this method. So again, as you can see, it does not allow us to change the reference. And so yeah, this is the point you need to understand, that we are not allowed to change the actual reference of the object passed of the object passed of the variable passed to the method. In this case, it's instance here, but we are able to change the values which are located under this reference, under reference 2, for example. Yeah, in this case. Right. Yeah, this is the way object-oriented programming works. Okay, so let's have a break, I think, and then we'll move on. Let's move on. Hello again. Let's move on. Yeah, as I promised, yeah, we'll go back a bit to the way how to clone the object. Yeah, just one thing, two things I missed. The first one, actually to use the method clone, we need to, in the class which will be cloned, we need to implement the. It is actually the interface. We'll talk later about the interfaces, but it must have the interface clonable to be assigned to be assigned to this class. Right? Yeah, this is the first step. So if you want to clone the class, you need to implement clonable. Is just the interface. You can add several interfaces to the class. In Java, it's possible, but yeah, you must add the interface clonable to be able to clone the class. After that, yeah, as we can see, that's the first step, and what it shows us here, it has the error. It shows that there's a handle and exception tab, call not supported exception. To fix this, just need to put throws call not support exception here.